and welcome to Fiberstar's third training session for tomato sauce applications using Citri-Fi. We want to thank you for attending this webinar, and before we start, I just wanted to review just a few basic webinar items. So this webinar is muted to provide you with the highest audio quality, and it will be recorded and available to you after this last session has been broadcasted. During this webinar, there's going to be 2 poll questions, and the answers to these poll questions will be shared to keep you informed about the market trends. You can ask questions at any time during this webinar. Please locate your question box, type directly into the box, and push submit. These questions will be answered at the end of the session, and if you have any additional questions, please contact your Fiberstar sales manager and we will follow up with a response promptly. Also, at the end of the webinar, there'll be a survey, and please do take a moment to fill this out because we use that feedback to improve future webinars. Fiberstar has over 30 distributors globally. Some of these distributors have been partners with us for several years, while some distributors are quite new to the Citri-Fi product. So when we do these webinars, we purposely create it for attendees of all varying levels of experience with Citri-Fi. So there'll be a little bit of repeating material in addition to the newly generated science and commercial successes that we're trying to teach you today. Okay, so first I'd like to just take a moment to introduce myself. I'll be doing the hosting and the technical session today. So my name is Dr. Kurt Vilwalk. Just a little bit about my background. I started about 25 years ago when I was doing dairy work at the University of Illinois. And after school, I went to work for a stabilizer, hydrocolloids and emulsifier business focused on dairy. After that, I left the industry to go back to graduate school at the Whistler Center for Carbohydrate Research at Purdue. And that's where I focused a lot on carbohydrates. Since then, I've worked for a number of ingredient companies, 2 large consumer food companies, and even an international agricultural cooperative. You might see as we go through these slides that there's going to be a focus on microstructure. That's a bit of a pet area of mine that I really enjoy because I can explain a lot about food just through the microstructure and the flavor. And between those 2 concepts, you can usually get a pretty deep understanding of what's going on as you try to develop food products. Okay, so let's get started. Today we're going to spend just a little bit of time on the basics of Fiberstar and its Citri-Fi line of products. We'll follow that up with some market insights by geographic region, and then we'll move into the main technical section where I'll try to teach you about why I believe that Citri-Fi 125 FG is a superior choice for tomato sauces. So this slide is a nice 1-page overview of Fiberstar and the compositions of our various Citri-Fi products. So it's important to note that Citri-Fi has a wide range of functionality, and therefore it also has a wide range of food types that it can be used in. Probably what you don't see reinforced here a lot, or maybe you do, but the fact is that Citri-Fi's best property is probably its clean label. And today we're going to try and focus on sauce applications that use the Citri-Fi 125 series here, and of course in sauces. So of those 4 series of products that we offer, 1 from pulp, 1 from peel, and then we have a couple co-processed products as well when bigger viscosity boosts are required. But we have each line comes in a number of grind sizes. So we have the standard fine, an M40, and even M20 in one case. Today we're going to talk about the 125 series, and specifically 125 FG. FG just stands for fine grind and corresponds to where it says fine here. So since many companies are looking to update their existing products to contain more clean label ingredients, it's good to know where Citri-Fi can function as a full or partial replacement. Um, in our case right now, Citri-Fi is going to be used mostly for replacing different hydrocolloids, chemical stabilizers, or chemical emulsifiers. I would also include, other stabilizers like guar gum that may be not so clean label in certain markets. But also, starches, particularly modified starches, and the like. The other thing is that, even though you you might be looking to replace, non-clean label ingredients, today it's going to be relevant to talk about replacement of expensive ingredients too, which could be tomato pulp or, other expensive fruit or vegetable pulps. So just take a quick look at the market situation in North America. So the concept of customized convenience is still going strong, but consumers are branching out more and more for gourmet or exotic flavors. So as a result of that, there's a lot more new line extensions, but the sales of the traditional condiments that have been around for 100 years are slowing down as a result. Nonetheless, the clean label concept is as popular as ever. I include a little bit in this presentation about prepared meals, and the reason why is that sauces often play a big role, especially in frozen meals and maybe pizzas or appetizers. Um, sauce can play a key role there. So the frozen food industry is in North America is still struggling a little bit due to a negative health perception, um, which in my opinion may be due to the fact that they have huge ingredient legends. If you look at the label, and it may be ripe for um, cleaning up the label to improve its marketability. So food service, as the economy gets better, people go out to eat more, so food service um, becomes stronger than take-home food. And we're seeing a lot more of these, as an alternative to frozen, we're seeing more like fresh, refrigerated type meal plan services, which are kind of new and exciting. In Latin America, there's this dichotomy of plenty of price pressure to keep the products cheap. But however, sporadically in certain countries, we're starting to see more of a push to regulate the food to remove salt and sugar and make it more healthy. In Europe, we find that clean label and nutrition are still often quite top of mind. Barbecue sauce is a trendy outlet for sauces at the moment, but in some European markets, they're for health or sustainability reasons, meat consumption is on the decline, and as a result, some of the sauces that are associated with that meat consumption may be impacted. Last but least, across the Pacific over to Asia, Australia, and New Zealand. Asia doesn't traditionally use as much tomato as North America and Europe, for example, or South America for that matter, but there's plenty of demand for table sauces of all sorts. And we'll talk a little bit later in the presentation about alternatives to tomatoes where this concept can also apply. And in Asia, we're starting to see a lot more international companies moving into some of the developing markets. Australia and New Zealand, the clean label movement is alive and well there. Health and wellness is still strong. It's interesting to, when you talk about clean label, to see what is clean label in different geographies, because something that's accepted in one region is maybe not accepted in another. But at this point, I'd like to just kind of break it up a little bit and throw in a poll question. So please help me get some responses for this poll question, because I'd like to hear what you say. And the question is, in your geographic region, what are the most prevalent tomato-containing products being purchased? Go ahead and check too, if you will. I'll wait for your vote for a couple minutes. Okay, just a few more seconds. And let's go 5, 4, 3, 2, 1. We'll close it. And I'll share this back with you here so we can talk about it. So with the audience on the line here, we're seeing interesting pizza and pasta sauces seems to be the #1 application. This doesn't add up to 100 because we had multiple votes per person, but interesting salsa and dips are quite strong here, and condiments and dressings is a little bit lower. I did a webinar last night with the groups that I think were mostly from Asia, and then the condiments and dressing was by far the largest one. So it's interesting to see how the geographies change. So I'm going to go ahead and hide that, and we can move on to the fun part, for me anyway, and that's the technical session. So if you look at the logo here on this slide here, it kind of describes how we try to present Citri-Fi, and that it's the sum of the parts. So there's that old saying 1 + 1 = 3. Well, I guess this would be 1 + 1 + 1 = 4 or 5 or something like that, because we have the soluble fiber, the insoluble fiber, and then the protein, and those components are just that. They're components. They're not purified or isolated or anything, and they're in this fiber particle that comes from citrus. Is still in its natural form, the way that nature put it there. So as a result, that kind of resulting architecture helps with its functionality, and we'll be able to talk about that in just a second. I've been talking for a while now. I want to make sure I introduce the concept we're talking about as we go forward. And so in a nutshell, this is what we're going to talk about for the rest of the presentation. So I've worked in the past in the tomato industry, and as part of making the perfect tomato sauce, I always thought, what are some of the best tomato sauces out there? And for some reason, I always think of like, a nice Italian grandmother somewhere, making this slow-cooked tomato sauce over the stove, and it's just delicious, and it's rich, and it's got flavor and all that. So I have this perfect Italian grandmother's concept in my mind. So as I was working towards, from a microstructure standpoint, what makes that work, I learned about different types of tomato paste. And so if you know anything about, tomato, the way they process it, there's, something called hot break and cold break, and it all has to do with how they process it so that the enzymes don't, destroy the pectin or modify the pectin. It's so important to the thickness. So, that's interesting, and a lot of people know that already. But the pectin alone, you can't make that really lovely texture. Think about if it was just pectin, it would be almost like a jelly or a jam, just with tomatoes instead of fruit. So what's the difference? And that the difference comes from the fibers. And so the fibers are the insoluble fibers that come from the cell walls of the tomato. And, it's just the same thing as like you might have in pureed vegetables, like if you were, have baby food or something like that. So that fibrous texture is, we take it for granted, but it's kind of unique in the sauce world. So, as I was looking for a place that I wanted to, build my career around, I came upon Fiberstar, and I rediscovered their products, and it occurred to me that Fiberstar with their Citri-Fi product had created a concentrated, and probably importantly, a dried source of cell wall fibers and really good quality pectin. And so if you look at that as like a nice powder, it's a perfect drop-in solution to food products that really benefit from that rich pulpy texture, that fibrous type of mouthfeel that's so important in tomato products. So that's kind of the story behind the launch of this application. And I want to explain a little bit about, for those of you who don't work in the tomato industry, what NTSS stands for. It's nothing to get scared about. It's really a simple concept. NTSS is the same thing as bricks. And bricks is just a measurement of, how much sugar is in, some sort of liquid product. You put it on a refractometer, real simple device, and it tells you 4% bricks. So that means there's 4% sugar or soluble stuff in there. NTSS just means the bricks that comes from tomato. So it's the natural sugars in the tomato. And so they use that as a way to keep track of how concentrated the tomato is. If you just press out the juice and mash up your tomatoes, it's going to be about 4%. Tomato paste is usually anywhere from 26 to 33% bricks or NTSS. If you start adding sugars and salts and stuff to your formula, then you can't call that part of the bricks NTSS. So that's where NTSS and bricks are different. But otherwise, NTSS is just the sugar in the tomato. So interestingly, the NTSS is just a general indicator of how much they've been concentrating that tomato. So what actually drives the thickness of the tomato sauce is really much more determined, as I said, from the pectin and the fibers. So we'll see how that comes into play with the Citri-Fi in a minute. So I'm not going to give you a big biology lecture here, but this is just a general schematic that's commonly used to describe how cell walls are put together. And cell walls are, in fact, the food ingredient that we're talking about, both with the tomato and the Citri-Fi. And so it's typically almost like a woven fabric. You got these cellulose fibers or microfibers that kind of make a grid network, and they're interwoven with hemicellulose and pectin. And that's the way that nature designed it. And the reason why you have this kind of rigid with these kind of more soluble-ish fibers in between is that allows it to expand and contract to absorb water and to help the cell grow as it needs to expand and so on. So the pectin in particular, the soluble fiber is interlaced in here, and you can actually squeeze it out with shear. It's not like attached permanently to these. At least that's what the scientists think. The hemicellulose is more attached. I think it's these red ones here. So they allow, they're kind of like tethers. They allow it to expand but not come apart. So Citri-Fi, both of our pulp and peel products are high in fiber, and 70 to 80% total fiber, and half of that is roughly cellulose. The other half is pectin, more or less. And you'll see that the peel product has a lot more pectin. And our Citri-Fi 125 product is not the same as other citrus fibers that you might find in the market. Commonly the citrus fibers on the market come from peel, but that peel has already been extracted because they're trying to extract the pectin to sell it into the pectin industry. So what they have is kind of a depleted cell wall that's much more reduced in pectin. So that's kind of a unique selling point for our peel-based Citri-Fi fiber. Okay, so I'm going to move on and start talking a little bit about texture. And what you'll find in the tomato industry is that when you try to extend tomato pulp or get more thickness from other sources than tomato, the texture can suffer. And typically what you'll see for thickening agents, you'll see things like, modified starches and gums. And, I'd like to propose that maybe the Italian grandmother wouldn't like to have that starch or gum in her tomato sauce. And the reason why is that it throws off the rheology, it throws off the mouthfeel, and can give, at least in the case of starch, I feel it can give a pasty texture. So from a microstructure standpoint, I like to look at these things. If you know about starch, it exists in the form of granules, little round spheres. And then as you cook it in water, they'll eventually swell. This diagram is actually for wheat starch, which is has kind of a funny shape when it swells, but more or less they kind of swell up like balloons and will eventually burst if you heat it enough in water. And if you modify it, maybe it won't burst; it'll stay swollen and so on. But then you've chemically modified it. So this, compared to the fiber texture, which I'm going to show you in a couple slides, it has that insoluble component to it, but the insoluble component is basically round spheres. They don't have the same mouthfeel as that fibrous texture. And then the other thing, especially in tomato's a high acid product. Even if you modify starches, they still have some susceptibility to pH. And also, if you're doing a lot of processing, shearing, and pumping, they're not as resilient as a fiber. Fibers are very resilient ingredients. They can take a lot of abuse. And starches, even when they're modified, they don't, they're not most recommended ingredient for frozen products due to their stability. So I'll make another case just talking about gums and hydrocolloids. They're often used to extend tomato paste. And so, you don't have that insoluble nature with gums because they are basically dissolved, but they're very big molecules and they bind up large amounts of water. And of course, that makes it thicker when you tie up all that water. But when the gum's in the sauce and then you put it in your mouth, your tongue and your mouth are actually really sensitive to rheology. And what's going on in your mouth is that you actually do have shear forces. We usually try to think of the shear forces right around 60 RPMs is a good place to think about what's going on in your mouth for texture. And, different gums, have this phenomenon called shear thinning where, as you shear it, the molecules kind of line up in a direction of flow and the viscosity goes down. And your tongue's very sensitive to that, and that's how you get some perceptions like sliminess or non-sliminess and so on. But generally with the kind of gums you see, like the xanthans and the guars, there's a sliminess or gummy component. And that's, in a tomato sauce, it's kind of an unnatural texture. So pulling this around full circle, I want to talk about how the tomato fibers are similar to citrus fiber. And, I got some pictures here just to kind of orient yourself. You were dealing with macerated, fruit tissues here. And so you have the cells there, and this, I just like this picture because, especially in the pulp of citrus, the cells are quite large. So this was under a microscope and this is not. But the bottom line is that these cells are made for containing water because of that. That's what their function is in the fruit. And, not all other fibers, like wheat fibers and bamboo, that's not their function. So they don't have the same architecture. But anyway, this is kind of the key point about texture is that the fibers, when you shear them up and you break down these fibers into smaller pieces of fiber, you increase the surface area, which increases water binding. But more importantly, in a tomato product, you also increase entanglements. So these fibers get entangled around each other, and that affects how the tomato sauce flows. So the pectin's in there, as we mentioned before, also, and especially if you have a good pectin, the way it works is that it basically glues those fibers together just a little bit, kind of adhesive. It's kind of like an adhesive between the particles, or between the fibers, excuse me. And that keeps the entanglements from basically unknotting. So you got this big snarl of particles, and I'll show you some pictures. And the pectin's holding it so that it doesn't come apart. And I know it's a little bit disgusting, but one way to think about this is if you have a cat and you ever see it cough up a hairball or something disgusting like that, that's really the texture you want at the micro level. You want those kind of entangled mass of fibers glued together. And that's those fibers, when they drag across your tongue, that's what gives you that natural mouthfeel. So here's another way to do it, to explain this more in kind of schematic terms. Cells are a key part of the functionality. So these circles represent the cells. And, in a tissue, they're all put together nicely in order. And then you go to make tomato paste out of it. And as it turns out, the pectin that kind of holds these cells together in this tissue, they're actually kind of the weak spots. So when you do some bioprocessing on it, like in the manufactured tomato paste, you get a lot of cells that are just kind of come apart, but are still more or less intact. And then you got some broken cells as well. So you have something that looks kind of like that. When you go to process it with, and you use shear to thicken up the tomato sauce, which is a common way for thickening of tomato sauces. What you do is you break up those cells, and then depending on how much shear you put, you get more and more kind of fraying of the ends and fiber creation. And also, during the process of that, shearing, you get these things really mixed together well so that they're completely entangled. So this is the concept we're going for on the right here as a natural, clean label and texture appropriate way for thickening tomato sauces. So how does this tie into Citri-Fi? We'll see here that the concept's quite similar. The product that we make here at Fiberstar comes from the fruit of the orange, and you have these particles that, they've been chopped up, they're kind of smooth. To keep it clean, we don't add any chemicals, we don't extract, we don't use enzymes, whatever. And we wash it and then pass it through this, our patented mechanical process. And really all that does is kind of rough up the surface, increase the surface area, and allow it to absorb water and oil much better. So, hopefully you kind of see the analogy I'm going to with the tomato, and that's brings us to the combination of the tomato and the Citri-Fi 125FG. Now, if you take a look at a, if you're a curious person, you try and look at a sauce, try to see the fibers. You can spread out that sauce and look at it carefully. You might see a couple big pieces of skin or something, the waxy skin or whatever. But by and large, those fibers, they're invisible, and it just looks, almost clear, and you can't see anything. But if you do the right stain on those fibers, and here I used a fluorescent dye that really lights up the fibers, you realize that there's a lot going on inside that sauce in terms of structure, and that's all those insoluble fibers. So here it is, just a normal tomato sauce, and this is what you get. This has been thickened with shear, and it's 12% NTSS. So that's basically, I took a tomato paste that was 31% tomato solids and diluted it down to 12 and processed it with shear and heat. So that's all that is. I even was able to stain the pectin, so you can kind of see a little bit how that works. But focus for now just on the green part and the entanglements there. So you can imagine this is entangled throughout like a huge massive sauce. So when it flows, it kind of rolls over each other and gives that kind of characteristic mouthfeel. And your tongue loves to feel those cell walls on the tongue, because after all, we're humans. We've evolved to eat plant foods and so on. So when you add the Citri-Fi 125, and then a little bit goes a long way, I found. What you do is basically you enrich that fiber phase. You get more entanglements, and more importantly, you thicken up the sauce in a way that preserves that fibrous microstructure that is so important for the mouthfeel. So I thought that that's interesting that these two are very similar. Just for contrast, I went ahead and did a similar experiment, only I added starch. I'll show that on the next slide here. And then you start to get a feel for, when you're adding starch and gums, what does that do to that tomato structure? So I tried it with two different starches, both a maize starch and a potato starch. Maize starch, especially in the U.S., is much more common. But there are starch companies that like to promote potato starch because it has such large starch granules. And you see these by the black spots here. And because they're so large, you can actually see them with the naked eye, and it impacts the visual texture. So you can see kind of pulpiness. But look what happens to that fiber network when you're starting to dilute it down with other thickeners. So these starch granules have been swelling, because this is a heated product. So the granules are swollen. And this used to be a big round granule, but it's kind of gone to the point where it's kind of burst and it's kind of melting apart now. But what you see here is that you got fibers that have big spaces in between them where the starch is kind of occupying the void. And what that does is that it takes away that kind of interconnected fiber network. It's almost like kind of a Velcro effect, when these things become entangled, and the starch is getting in the way of that and ruining it. And then the continuous phase of this is becoming more and more like starch. So it's starting to dominate the rheology and the mouthfeel. and that's how you get that pastiness. Same thing happens even though the granules are smaller with a cornstarch. They're getting in between these fibers and they're isolating the fibers into smaller and smaller pockets instead of having that big long entanglement. And then just for reference, here's the original tomato sauce. You can kind of see the entanglements. This was just a big tomato cell at one point. You can see kind of the remnant of the cell there, and that big seed there. So that's, in the microstructure terms, that's what's going on in terms of mouthfeel when you use non-fibers to thicken a tomato sauce. So I kind of like the pictures because as they say, a picture says a picture's worth 1,000 words. But for the engineers in the group and all people who like more data-driven stuff, here's a quantitative graph of what's going on when you thicken tomato sauce. So like I said, people have known for a long time that you can thicken tomato sauce with shear. So all we have here is a graph where viscosity is going up on the vertical axis. We measure that with a Boswick. I'll show you that in a minute. And here we have increasing shear that we use the homogenizer for this one. And so, like I said, as you shear up the tomato, you get more and more viscosity, and then eventually, you keep trying to shear it up and squeeze more thickness out of it, but you get diminishing returns as you go up to the higher amounts of shear. So as I mentioned before, Citri-Fi is a nice drop-in solution, so we can literally concentrate that. In this tomato, there's just a little bit of tomato fiber and pectin that's naturally in there, at least if you think about it as a percentage basis of the whole sauce. But it's very important for thickening. So what we've done is we just dropped a concentrated slug of Citri-Fi 125, which is similar pectin and fiber. And as you increase the shear, you get this bigger boost as you go higher and higher in shear. And that's because the shear has more kind of ammunition or more fuel to work upon because you've had that added fiber. So this is the this area up here is kind of the sweet spot for getting more value out of your sauce, and then has cost out implications as well. So like I said, the shear also has to be kind of commingled with the tomato because they're working off of each other. It's not like starch where it just thickens on its own. The Citri-Fi fiber will work together with the existing tomato fiber as kind of a system approach. So there's two ways, from a benefit standpoint, there's two ways you can look at this. And one is to reduce the costs, and maintaining the texture and flavor, up to a point. You can't drop out all the tomato. Obviously, it's not going to taste like tomato anymore. But you can reduce, a certain amount of tomato paste and keep the color and flavor in check. Or if you're looking more to drive preference, improving the quality of the sauce, the Citri-Fi tomato sauce concept will improve the body, and surprisingly, both the color and flavor are improved as well. So I think right here, I'd like to go ahead and break it up, and again, with a little bit of a poll question, and I'll launch that now. And I'd like to see what you have for answers for this one. So the question is, what segment drivers do you think are driving sales of tomato products in your region? So go ahead and punch in your results. You can pick up the two. I'll just give you a minute or so just to fill that out. What market segment drivers do you feel are dominant in your geographic region? Got about 50% voted. I'm just giving, a few more seconds. And 5, 4, 3, 2, 1. Close. And let's see what people said. Okay, so according to this survey, taste and texture is king. I've worked at a number of companies, and that's always been a slogan, taste is king. But the reality is cost is important too, and I see that there. But for the market that's on the line right now, I believe that quality is appears to be very important with the clean label and the taste and texture. And I'll be curious to find out what that other is. Okay, so I want to talk a little bit more kind of on, less science and more applied. And so I have this slide here. It basically shows, how to make a very simple tomato sauce. There could be all sorts of different formulas that contain tomato. It could be, a barbecue sauce, or, pasta sauce is pretty straightforward, but there could be condiment. And all those sauces, when you formulate with them, they have a certain amount of tomato in them. And that's, most formulas I've seen, they list that as NTSS. So, your barbecue sauce may have 5% NTSS and then a whole lot of other stuff, like, vinegar and syrup and who knows what. But, 5% tomato solids, or your pasta sauce might be, 15% NTSS and be really rich in tomato. So the formula would probably give a percent NTSS to target, and all you have to do is figure out, how much tomato solids you need for your formula. So if it's 12%, you need 12 kilograms of tomato solids for every 100 kilograms of finished product. And then you just figure out what your source is of the tomato. And so if you're using paste at 31% like I did, then you can just back calculate to figure out how much paste you need to deliver that amount of solids. So it's pretty straightforward. Working with paste is not easy, so because it's kind of messy. It's a little bit like wasabi sauce. If you've ever had sushi, if you don't cut it with the water carefully before you, or the soy sauce in case of sushi, if you don't mix it gently in the beginning, you're going to have big concentrated clumps everywhere, which can cause trouble. But all you have to do is make sure that it's dispersed, and there's equipment that can do that if you have that kind of equipment. And then you add the Citri-Fi 125 FG slowly and mix vigorously. Now I was adding it directly to the tomato slurry, the paste and water, because I wasn't adding any other ingredients, because I was just doing a simple sauce. But if you have the luxury of adding it with dry ingredients like sugars or salt or whatever, it's best to just mix them in with the dries first. So you don't have to be as careful when you mix it in, or it's a little bit more tolerant. It doesn't form fish eyes. So all we did is we heat it, and we pumped it into a homogenizer and sheared it. And then we collected our samples by hot filling. All right, so I mentioned Bostwick's before. I'm sure some of you have seen Bostwick's before, but just in case, I have this slide here. And Bostwick is really interesting. It's a very simple device. It just has this kind of trapdoor guillotine-like thing that holds a reservoir sauce, which is just off to the left of the picture here. And then when you click the button, you open the trapdoor, it springs up on a spring really fast, and you start your timer, and you wait 30 seconds, and you see how far that tomato sauce travels down that trough. And it's on kind of a small angle, downward angle, so gravity pulls a little bit. So all you have is centimeter marks there, and you measure how many centimeters it flowed. So if it flows a lot, it's going to have a high number, and that means it's probably a thin sauce. So lower numbers are thicker. So, and here we just show the samples that were made 12% in TSS with no additives, and that type of homogenization got us a 6.3 in a Bostwick. So that's a respectable tomato sauce. However, when we added just a tiny bit of Citri-Fi 125 FG, the Bostwick went down to 4.4. So in terms of Bostwick centimeters, that's a significant increase in thickness, almost 2 centimeters. So, and one thing I have to caution on this is that when you do these types of studies, it's important to use the same lot of tomato paste, because tomatoes are a natural product, and there's a lot of variability in not just the processing, but the average ripeness of that batch that was processed has a lot to do with the pectin quality and the thickness. So, so keep in mind when you're doing comparisons, they have to be apples to apples. These next two slides are literally verbatim from the application sheet that we put out, which is available to you. And basically, two slides are on, it's on a one-pager, but I have it on two slides here. And the first part of the application just talks about the general value proposition in a nice kind of concise way, without getting too much into the weeds and the technical stuff. And then the other part of the application sheet has a simple formula for reference. And what I like about this is that it shows, the snapshots of the two sauce. And to me, the one with the Citri-Fi definitely looks richer, and the color is a deeper red. And I thought that was really, really interesting, because for those of you who worked in the tomato industry, there's kind of a general skepticism when you start adding things to tomato sauces. They tend to either start turning pink or turning orange, as a general rule of thumb, with some exceptions. But so I was really pleasantly surprised that the 125 actually helps with the color, gives it a more of a red impact, and if you can look carefully and see kind of the texture, it definitely looks thicker and richer. So I kind of described previously how you manufacture a sauce, so it's listed here again. Just remember that when the sauce is finished, we filled in the containers because we were just going to hold on to it that way and keep it in nice sterile jars. But in other industries, they might take that sauce and put it right into a frozen prepared meal, or even mix it with another condiment. So you could thicken this and add it to other things as a component. And then lastly, this is a sauce. It comes from it's commercially available here in the U.S. It comes from a restaurant chain that I really like, but I like to pick on their sauce because I think it's a kind of a poster child for what I think is a negative texture in a tomato sauce. And the ingredients on this are, it's all based on modified starch and xanthan gum. And so especially when you pour it like that, you can really highlight how it's got that long, sometimes people call it a snotty texture or slimy texture, and it doesn't have the same mouthfeel. So that's, in terms of a value proposition for texture, that's kind of what I'm going for here. So we did some sensory studies, just internal, but we did them blind, so nobody knew what was what. And what we did is we confirmed that the panelists thought it was redder with the Citri-Fi in it, which you can see in a previous picture. And also, I'm in the process of updating the slides, but I'm actually going to get colorimeter data that gives you actual, Hunter LAB values. That the A value is a way to quantify how red it is, and the L value tells you if it's light or dark, and then the B is something else. But you can factor it in, and then actually have quantitative data to verify the color, in case you have any skeptics. But once again, the thickness was higher, as you would expect. Flavor intensity was about the same. But what's interesting here is we start talking about preference. There's something going on with the preference. The texture is improved somewhat over the control. The flavor seems to be improved even more, and the overall preference was certainly improved. So, for sensory result, that's as good as you could hope for, I think. And so that's a unique property of the 125 FG. So for those of you who are more interested in reducing the amount of tomato you use, it's possible to do that as well. Just in my initial studies here, this is kind of where we're netting out in terms of cost out. So it's kind of a funny way to present it, but bear with me. So you see this bar graph. These are basically different samples that I can create with different levels of tomato. I maintained the Citri-Fi at 0.3% and just tried to see how low I could go on the tomato pulp content and get the same viscosity as the control. So, if you take out 4%, if you take out 4% paste, you still have a little bit of input costs from your Citri-Fi, of course. And what we found is that right around 6% paste reduction is where you break even on that. So you get equivalent viscosity. I mean, you don't get equivalent viscosity, but you get equivalent cost at about 6% paste reduction. So this, as you get closer to where we can match the thickness, which is what I've tried to mark here, between somewhere in here, you get about 10% paste reduction, and you're starting to do the cost out range. So the numbers are what they are. They're definitely not cost in, and you can save a little money as well. And what we're also doing is we're looking at going to even higher pressures. We kind of standardize at 2,500, but we know that we can get more of that synergistic viscosity impact at higher pressures. So we're going to update our material to show that as soon as the work is done. And the other thing I mentioned here that I mentioned before is that the results you get are not, one single number, because the effect is also dependent upon the quality of the tomato used. Okay, another application note here. I kind of hinted about this earlier, but a lot of maybe your consumers or the certain product type that you're interested in, super smooth puree is not going to cut it for you. So, you might want something that has more visible tomato structure in it, or even maybe onion pieces or spice, maybe a little cilantro in your salsa, something like that. And so the solution for that is to have kind of a two-component system. And this is done in the industry. So, for example, a lot of canned sauces for restaurant use, they'll have, diced tomatoes, for example, and they'll fill the dice into the can first, and then they'll take it to another station where they kind of top it off with the juice. And the juices really could be a thickened tomato sauce, or the concept I just presented with the Citri-Fi thickened tomato sauce. So it's important to keep an open mind, and that you can use this concept in a more multi-component system. It's nothing strange. So that's that. And then, so I want to talk a little bit about tomato sauce and more of a compound food again. And I just threw out an example here just to kind of help you think through, application uses. We've been focused on the texture and the viscosity of the tomato sauce using Citri-Fi, but especially for those of you who know the other properties of Citri-Fi that we didn't get into in this presentation, those still apply. Those benefits are still there. So if I was just going to do a checklist of what we could do to a frozen lasagna, this would be kind of an example of what I would say. So we have the improved body or the cost out of the tomato sauce, as we just mentioned. But in addition to that, our Citri-Fi products are also really unique natural emulsifiers. So how does that work? We found that it's very good for products that contain meat or fat, even cheese, if it's kind of an oily type of cheese, that it's very good at keeping that fat homogeneous with the surrounding sauce. And that's because, the way it emulsifies isn't, like a chemical emulsifier where, you're making a mayonnaise and you got to shear it up and make small, tiny droplets and then coat those with a chemical emulsifier. It has a very different mechanism that allows it to control oil in a much more passive way with less shear. So those benefits are in play here. Freeze-thaw stability, we know that our Citri-Fi products are quite good for preventing large ice crystal formation in ice creams, for example. So in a frozen food product, having that sauce and all those layers can help control the water during freezing to prevent those ice crystals. And of course, Citri-Fi is a strong water control agent. So it's always useful for sauce syneresis control, which is where you get the pooling of the water on the top. We've even seen evidence that because of its strong water binding ability, we can control condensate and package. And so that has a play in terms of microwavability. If you got like a frozen microwavable meal and you cook it and you get all that condensate on the top and then it drips down and kind of ruins the sauce and the texture. So it has a some benefit towards improving the microwavability. Then also, you want to put a lot of fresh vegetables in there. Well, they tend to not hold their water so strong once you start manipulating them. And so the water control from the citrus fiber can also benefit that. And last but not least, we see evidence both empirically and we have some sensory data from the expert panels at the University of Minnesota that shows that when you use Citri-Fi, it improves the sodium perception, or some people, when it's used in meat, they almost they want to call it umami or something like that, but it's kind of that savoriness, if you will. The Citri-Fi tends to enhance that a little bit. That's more of a side benefit. So there are another number of other, potential products out there. We've already talked about the modified starches, and the xanthan gum and guar gum probably can be thrown into that argument as well. And some of these are considered clean label, some of them aren't, depending on your market. But what the takeaway from this slide to me is that it's very hard to find a clean label solution for this, for thickening a tomato sauce that doesn't carry a lot of baggage on the flavor, or texture, or color for that matter. So I think that's why Citri-Fi 125 is kind of firing on all cylinders for this application. So we have this slide here, and this is a slide that we use quite often in our training seminars and presentations. So Citri-Fi, and here we're just showing the 100, even though we're talking about the 125 series in our tomato products. We know it's one of the strongest has one of the highest water holding capacities of similar ingredients. And there are other products out there that also have high water holding capacity, and this citrus peel fiber here, this is not ours. This is one of those products that I mentioned earlier, where it's kind of the leftover remainder after they extract the pectin out for pectin, basically for the sale of pectin as an isolated product. So that fiber is not the same as Citri-Fi 125, but it has a high water holding capacity. When you just do the simple test in a nice centrifuge tube, and you just kind of see how much it soaks up, that type of assay. But what we found in a lot of these products, that once you start manipulating it, in a process where it's moving around, it's getting sheared and cooked and pumped and who knows what, and a lot of the fibers that are normally good in kind of an a static situation, they'll give up that water, and that's kind of what we're showing here. Is that Citri-Fi is a very tenacious holder of that water, and some of these, like the potato fiber, give it up right away. So that's important to keep in mind as we talk about functionality. So just a quick summary slide. Hopefully by now you understand what I'm trying to say here about the tomato sauces. The mouthfeel and the texture is improved by this concept. It's clean label. The water holding has a lot of extra benefits, and there's a cost reduction component to it as well. So before I let you guys go, I wanted to make sure we hit upon emulsified sauces, and the reason why is because emulsified sauces are often of interest to the same people who are interested in tomato sauce. Citri-Fi products are a natural emulsifier, as I mentioned, and they can form emulsions that are very stable with very little shear. So you can see this for application, maybe like a delicate sauce that has an emulsion that can break easily. And also, like I mentioned before, with the meat and gravies and marinades, when you're working with meats and oily things, Citri-Fi is quite good at keeping those sauces that are connected to it so nice and homogeneous. And I kind of like this picture here. That this is from culinary circles, the 5 mother sauces that a lot of other sauces are made from. And I'd just like to point out that tomato is unique. The chefs, they understand that. It's a very unique texture, and that's because of that fiber concept. But here you also see some of the emulsified sauces. So just a quick picture just to illustrate that point. This is actually a soup, not a sauce, but the concept still applies. And here's a soup that had, an oiling off issue without adding the Citri-Fi. Adding the Citri-Fi, in this case it was 100 M40, but the 125 FG also does this. And that's, keeping those grease puddles under control and keeping it more homogeneous. And some sauces, actually, you might even mix tomato and an oil. Okay, so this is the last slide I wanted to put up here just for food for thought. And so applications that, could exploit this concept, the obvious ones are, the tomato sauces and the Italian meals, pizza for sure, pasta sauce, and tomato-based condiments like ketchup and barbecue sauce. But especially for markets that don't have a lot of tomato products or just in general, this concept could be applied to other products that are basically macerated vegetables or fruits because they all have that same type of texture. So that's why I tried to put some visual cues here for like tomatillo. It's not really a tomato, but it's the same concept. It's, macerated, tomatillo fruits. Or a pepper sauce, that's where you get a lot of the texture from the ground pepper. And, and that threw mustard up there, even though it's a seed, but, mustard has, major issues with synergies and things like that. So it could be beneficial in there as well. And even certain types of pureed soups I could see as a potential use. So it's just kind of some inspiration, maybe some inspiration for creativity. So thank you all. I wanted to mention that in the actual deck, there are a number of optional appendix slides. I'm not going to spend any time on those today, but if you're curious about how to talk to them, please reach out to me. And with that, it concludes today's session, and I'd like to thank you all once again for attending the webinar and for your attention. Please contact your Fiberstar sales manager if you have any additional questions, and I'm always available if you have any technical questions about the concept. We'll try to get through as many questions as we can. If we can't get through them, I'll ask the technical service person to follow up with you. So I'm going to take a look at the questions here. And let's see. So is Citri-Fi 125 organic compliant? I am going to send that over to my quality person and get back to you on that one. I believe it is, but I don't like talking about it until I have all the facts, and I've been focusing much more on the technology. So I'll get back to you on that one. This presentation is a question about whether it will be available at the distributor portal, and the answer is yes. If you have any suggestions for how to modify it for your customer or clients or whatever, please let me know. I'm willing to take any suggested edits for sure. Last question is, what's a typical usage rate range for 125? And I think I mentioned before, I think a little bit goes a long way. What we found is that when we go up around, 0.8, it's not like a linear effect, like more citrus fiber gives you more thickness, because I think it has to do with, its ability to interact with the shear and all that. So we're recommending levels 0.2 to 0.4 right now, maybe 0.6. Especially for cost out, you probably want to keep that number low. But I mentioned I'm going to be doing more work on higher shear systems, and I suspect if we go higher shear that we can probably take on more fiber and get an even higher thickening effect. So so that's coming in the near future. So it's now 11 o'clock here in my time, which means that we've used up all our time. I want to be respectful of your time. So any more questions here, we'll be happy to answer. But with that, I'm going to close the presentation. Thank you once again. I really appreciate you attending. And if you don't mind doing the survey afterwards, that would be appreciated as well. So thank you all and have a great weekend. Bye-bye.